Even if you're very new to Unity, chances are you're already familiar with access modifiers. These are the keywords that you put before your variables or your methods that determines the scope of them. Where the public keyword means that your variable is accessible to all classes within your game, the private keyword limits the scope to within the class that it is defined. And what I tend to see most often is an overuse of the keyword public and an underuse of the keyword private. And so what I want to do with this tutorial is to give a very simple example to discuss when to use public, when to use private, and we'll even cover protected. So let's get started, shall we? To start with, I have a very simple scene set up. I have a player object represented by the blue capsule, and I have an enemy cube, and also some text at the screen just to display the player's health. And so what I want to do is to create a script that will monitor and control the player's health, display the health on the text, and then I want to be able to damage the player when the enemy comes in contact with the player. So to do this, we'll start by creating the player health. So we'll go new C# script, and we'll go player health. So we'll open that up in Visual Studio. Or maybe not. There we go. Nope. Yep, thanks. So let's try that again. There we go. Okay, so the first thing I'm going to need is somewhere to store the value for the player's health. And this is a great use of the word public. Public float player health. Since other classes and other objects in my game are going to want to be able to read the player's health, this is an excellent use of when I would set it to public. I will also create a public method to go along with this called public float, and we'll call it damage player. And this will take a float called damage. And all I want this method to do is to subtract the damage provided from the player's health. So player health minus equals not plus damage. Oh, and what I don't want to do is return a type, so I'll go public void rather than public float. And there we go. Let's just save that. So we got a method that other classes can use called damage player, and other classes could also just read the player's health. If I was doing this for my own game, what I would do is set this as private and make a public get method. So that way other scripts can't directly set the player health, but merely read it. But for today's example, this will do just nicely. We don't need the start and update method in here. In fact, I could get rid of mono behavior altogether. But we'll leave it at that for now. So we'll save that out, and we'll go back to Unity, and we'll just add that to our player object. And so we'll go add component, player health. And you can see because it's public, I can set it in the inspector. So I'm going to set it to 100. Easy peasy. So now what I want to be able to do is display that health on the screen. Pause. Yeah, need to drink water. All right. So I will create a new C# script called display health. And we'll open this in Visual Studio. So because this is going to be attached to my UI text object, I'm going to need the namespace of the UI. So we'll go Unity engine.ui. Okay, and then what I'm going to need is a reference to the text object so I can set it every frame. And so because there's no reason for any other class to access this particular reference, I'm going to set it to private. So we'll start with private text, and we'll go health text. Other objects may indeed want to change this text or be able to read this text, but there's no need for them to access this particular reference within the display health class. So this is a perfect use of private. And so of course I need to actually set this reference up. So I will, in the start method, go health text equals get component of type text. And that's perfect. Now we need to set the text. So I need it, in order to do that, I need a reference to the player's health, which I can get from the player health script. And once again, there's no need for another class to access this particular reference for the player health. So once again, I'll use the private keyword. Private, and we want to reference the player health class, and we'll call it health. Okay, so now I have to set up this reference. There's a couple ways I could do it. I could do find game object in the scene and get component from the player. But what I'd rather do is set it simply in the inspector. But if I save this out and I go over to Unity and I go to my text object and I go add component, display health, it does not appear in the inspector for me to drag in the player health script. But I can fix this. And this is one of the common reasons I think people overuse public variables, is simply so they can edit it in the inspector. But what we can do is we can make use of a tag called serialize, spell it correctly, serialized field. And what that does is it allows this private variable to appear in the inspector. So I'll save that out. It's still private, so other classes cannot access it. But if I jump back into Unity and I let it recompile, you can see now it has appeared in the inspector. So what I can now do is drag in my player object and set the reference up that way. And so this works for any other variable you're doing. So perhaps you want to maybe set the speed or the health of an enemy, but you want it to be private, or it should be private. You can use the serialized field so that you can still edit it in the inspector, especially at runtime or during gameplay. If you're testing out things, you want to be able to change the variables. This is a great use. So we still need it to actually display that health, so we will go to health text dot text equal to, and we will just write in player health, and we will go plus. So we'll use our reference to the player health class. So we'll go health dot, and if I type in player health, you can see that value for the player health, because it's public, has easily popped up. And of course I need to set this to a string, so I will go to string and close that off. And that's all done. So jumping back into Unity again, if I hit play this time, or hit run, it's gonna be a bit slow. If I go over to the player and I change the player's health in the inspector, I can see that is changing the health on the screen. So that's excellent. So that's a good use of public, so being able to read the health of that, and we've made use of private variables and the serialized field. Now what I want to be able to do is damage the player. So we're going to create an enemy class. But in your games, you may have multiple types of enemies, and so you may want to set up a generic structure for your enemy. So I'm going to set a enemy class. Whoop, if I could spell enemy, and we'll open that up. And so this is going to be a generic class for my enemy. So I will set up, so what do I want? I want my enemy to have a health, and I want it to have a damage value. So how much damage will it do to the player? And then what I'll do is I'll create a method that will damage the player. And I want all my enemy types to do that. But I'm going to have my specific enemy types inherit from this class. And so this is a great use of the protected keyword. So instead of private, I'm going to use protected float, and we'll go health, and I will go protected float called damage. And I want to set up a method, so we will go protected void called damage player, and it will take a game object called player. So if we pass in the player, what we will do is use the player's health script. So if we're sure it's the player, we should be able to access the player's health script by going player dot get component of type player health. And now I'm going to call on that public method we wrote earlier called damage player, and I'm going to pass in the damage attached to this script. So, and I won't need the start and update methods. But if you notice, the start and update methods, they don't have either protected or public in front of them either. But it turns out if you don't define the access modifier, it defaults to private. So for example, if I delete this and I go to add it again and I type start and I let it autofill for me, you can see it automatically fills in the private keyword. You could change this to public, and now I have my start method of my enemy class accessible to other classes. There's seldom a use case for that, but just out of interest, if you don't define the access modifier, it is by default private. But we're talking about protected now. So I've got a generic enemy class that has a health, a damage, and it can damage the player, or a method to damage the player. So I will now save this out. Now I want to create very specific types of enemies. So I'm going to create a cube enemy. So since I have a cube in my scene, we'll go C# cube enemy. And what I'm going to do now is, instead of inheriting from mono behavior, I'm going to inherit from enemy. And since enemy inherits itself from mono behavior, the start and update methods still work, which is fantastic. But importantly, because I'm inheriting from the enemy, these protected variables are accessible to me within my cube enemy script. So what I will do in the start method, for instance, is I'll set a specific damage. So I will go damage, so inheriting from the enemy class, damage equals, and we'll go 10F. Right, so, and we'll go health of the enemy class is equal to 30. And so you can imagine setting up, a generic enemy with all the methods that you want the enemies to do, and then creating specific behaviors for the different types of enemies within your game. And so now what I want to be able to do is damage the player. So I will use the mono behavior on trigger enter. So I've already set up the colliders on these objects. So on trigger enter, and we'll say if other dot compare tag So if it is the player, what we want to be able to do is damage the player. So we want to call that method from the enemy class. So we can just go damage player, and we can leave it at that. So that's calling the damage player from the enemy class. Now, of course, we put a parameter of GameObject_player, so we need to pass in other.GameObject, which is our player. And so if I just tidy this up a little bit. So when our cube enemy enters or collides with the player, it will use the protected method of damage player, which is calling the public damage player method within the player script. So if I did all this correctly, we can jump back into Unity, and I will add that enemy cube. So I'll go add, and I'm not going to add enemy, I'm going to add cube enemy. And so if I hit run now, nothing happens yet, but if I drag my enemy over and collide with the player, you can see that the player's health is dropping by that set amount. And there you have it. That is a use case for protected variables. So just to quickly summarize, when you want to use a variable or access a variable or a method within another script, you could use the keyword public. Otherwise, you want to stick to private methods or private variables. And should you need or hit the dilemma where you need to see the variable in the inspector, either for testing purposes, you can use the serialized field tag. So there's no need to set it to public just so you can see it in the inspector. Use the serialized field tag. And of course, if you're inheriting objects, you can keep them as private or acting as private by using the keyword protected. Hopefully that clears it up for you, and keep on gaming.